Hi friends, welcome back to my channel Testing Mini Bytes. I'm your friend Amazon Saktivel, and in this video we're gonna see about predicate interface and its usage, right? So as the name suggests, it's predicting whether something is true or false. So even the method name is test, so it's going to test something is true or false. So method signature is very simple. It has one abstract method called as test that going to take in some kind of value and going to return you a boolean. It can only return a true or false. Very simple interface, but it has a lot of usages in test automation space as well as Java. Good. So it also has some default methods like and or negate. We're gonna see what are those things. And it also has a static method called isEqual. But there are so many assertion libraries like assert JUnit. They can help us to use their behaviors instead of this is equal. Again, you can also use this is equal from the predicate interface. Good. It is also having a BiType. That means it takes in previously the predicate interface takes one single argument and returns a boolean. Now BiPredicate takes two arguments and it returns a boolean at the end of the day. Okay, whatever the operation you can do, yes, but at the end of the day it has to return a boolean, true or false, right? So first we're going to see some simple examples about how we can use predicate interface, what is predicate, how we can achieve the predicate chaining and all those stuff. And then we'll also see a simple use case how we can use this in a particular use case of sum of integers, right? I'll explain those in detail, and we'll also see about different use cases in the upcoming videos, but for now we'll see only the basics and the use case one. Good. Let's, without wasting much time, let's get into the workspace. Good. Good guys, if you notice, I want to show you guys how the predicate method class look like. If you notice, this is a functional interface, right? So it has a method called test, and this is a abstract method that takes in a single argument and returns a boolean. It also has and, or, and negate, three methods. We're gonna see what are those things, and it's also having a static method called as isEqual. That's what I told. It's gonna do the objects check whether this particular object is matching with another object, right? Good. And it also has, we also told this, there is a BiPredicate functional interface that takes in two arguments and returns a boolean. It also has and negate and or. It doesn't have the static method is equal. Good. So we're going to use it in our code, and let's understand how this actually works. As we know, predicate is an interface that takes in an argument. This argument can be anything. Maybe in my case, let's assume that I'm passing an integer to this. Let's have a use case whether I want to check whether a number is an even number. Okay, in those cases, right, it takes in an argument. So let's give an argument. Let's assume it's taking an integer, and I want to return an output that is a boolean, right? It has to be either true or false. So what I'm doing, I'm going to check whether it is when we divide by 2, whether the remainder is 0. Then this is an even number, right? Suppose I want to see whether it is working fine, then you can use sysout statement, and I'm going to check is even dot test. There is a method called test. That's what I'm calling, and I need to pass a number. What number you want to check whether it is even or not? Okay, I want to check whether 8 is even or not. Yes, we all know 8 is an even number, but check whether it is giving us the right answer. Good, it is returning as true, which means 8 is a even number. So let's change it to 9 and then check whether it is returning false. Yes, basically it is doing the same operation. Yes, it's working fine. So now we have written a very simple lambda, and if there is only one argument, you don't have to mention the brackets. So now this becomes more neat and clean. Let's understand. Suppose I have a need whether I want to also check whether a number is an odd number. So what I normally think, I try to write the same line of code, but this time when the I modulus 2 is equal to 1, or basically it can be not equal to 0, anything, but for now simplicity I'm just telling like this. Okay, so I can also check whether it is okay, is odd, okay, and is odd. Okay, now it should return me true because 9 is an odd number, right? Good. So but if you notice, a number can be even or odd. Okay, this is just a negation of this, right? So which means if a number is odd, it cannot be even. If a number is even, it cannot be odd. So it's just a negation, right? So instead of even writing like this, what I can also do, there is something called as is even dot negate. Okay, which means, whatever the value that it's giving, suppose it's returning true, okay, it's going to convert into false. Okay, if it is returning false, okay, the negation will return true of it. Just a inversion. Okay, if it is returning true, it will change it to false. If it is changing to, if it's giving false, it will change it to true. So I'm just checking is even dot negate dot test. Okay, I'm going to test, okay, whether this number is odd, because is even dot negate is nothing but odd. Okay, let's try to run the test and check whether 10 is an odd number. Obviously it will return false. Okay, even it doesn't mean you have to use it here. What I can do, I can do is even dot negate. Okay, and then here you can previously use like this is odd dot test 9. Okay, so this is gonna work the same way. So the negate is going to inverse the operation. Okay, whatever it's returning, it's going to convert, invert that. Okay, good. Now we have understood about these things. Suppose I want to check whether a number, is divisible by 6. Okay, when will be a number that will be divisible by 6? Okay, if a number is divisible by 3 and it is also divisible by 2, then it is divisible by 6, right? So let's also introduce one more. Okay, is divisible by 3. Okay, then in those cases, so this is going to check whether it is divisible by 3. If something has to be divisible by 6, it has to be, we need to check whether it is even dot, there is an uncondition. So here I can tell, is divisible by 6. If a number is divisible by 2 and divisible by 3, then it is divisible by 6. So actually I can check is div by 6. Okay, and here is div by 6. I want to check whether 12 is divisible by 6. Okay, yeah, it is true. Good. So this is how we can do the chaining of the predicates. Previously we used negate, we used and. There is something called as or. We can also use or. Maybe we can take a different example than an integer. Let's assume we have a predicate that takes in a string argument and it is checking whether it starts with a. Okay, whether the string is starting with a. If someone is giving me yes, I'm going to check whether it is starting with a. Okay, as simple as that. I also want to check, okay, predicate that again takes in a string is starts with b. Okay, someone is passing me yes, I want to check whether it is starting with b. Okay, but I have a requirement now. I want to check whether a string, okay, whether a string is starting with a or is starting with b. Okay, then in those cases I can just use is starting with a dot is or is starting with b dot. Yeah, that's it. So I'm gonna check is it starting with a or it is starting with b. Okay, let's try to use it in the code. Maybe I remove this, I introduce a new one. Let's take is starting with a or b dot test. Let's pass Amudan here because this is starting with a. Obviously it should return as true. Let's check. Okay, so this is how we can also use or operator. Okay, suppose I'm passing b here. Okay, some name like this, then okay, it's still gonna work because it is starting with b. Suppose if I use c, it's gonna throw me an error, right? Sorry, it's gonna return me false. Okay, so this is how we can do the chaining. So there is negate, which gonna convert your true to false or your false to true. There is something called as AND operator where it gonna check whether it is even as well as it is divisible by 3. there is or operator, whether it's gonna work like your normal or operation, right? Good. So this is how basically it works. And what else we have? We have something called as BiPredicate that we can use. So BiPredicate is basically that we want to take two arguments. In my case, let's assume I'm going to take two strings. Actually, I have created BiPredicate with strings, but I forgot what I want to do. Maybe I compare uh, is length matching. Okay, let's name it as is length matching, which actually gonna check whether the two strings are having same length. So what I gonna do, it accepts two arguments, and at the end of the day going to check a dot length equal to b dot length. Okay, as simple as that. So here you can also enter, okay, uh ouch and is length matching dot test. So this time it takes it two arguments. I need to pass two arguments, and let's assume I am passing sky comma fly. Okay, okay, so I am passing two arguments and both of them are having three characters, so it should return true. So this is the operation that BiPredicate does. The only difference is it takes in two arguments. Maybe I can give a small example with integer as well. Okay, it is not just it has to take the same arguments, it can also take string comma integer, it can also take different things. But yeah, but what I'm going to do, I'm going to take a simple example. Again, it takes in two arguments, and I'm going to check is sum divisible by 10. I'm going to get two numbers, I'm going to sum them and I'm going to check whether the sum is divisible by 10. Okay, so I'm passing two integers and I'm checking whether a plus b modulus 10 is equal to 0. Okay, so again I can write it in here is is sum divisible by 10, and here the test, I want to pass two numbers. Let's pass 3 comma 7 and expect a true from here. Let's try to run the test. Yeah, we are getting true. So this is how we can use a BiPredicate, predicate, and then chaining. Again, guys, this is very simple use cases, right? Let's take a real-time example and then we'll try to solve all of these. Let's remove all of this. Okay, I feel this is a little noisy here now. So I removed all of them, and let's take an example that your manager wants you to create a method that that takes or that calculates sum of list of integers. Okay, this is your use case. Okay, okay, this is pretty easy task manager, I can do it in 5 minutes. Okay, let's do it. Okay, let's first create a list, okay, of numbers. Basically I have used from 1 to 10, but yeah, I'm gonna create a method that takes in some numbers and it's going to print me the value. So for that, I can initialize some variable sum equal to 0, and I can run a for loop and till the numbers dot size, and also what I want to do, I want to do sum plus equal to numbers that get index, right? Good. Once you calculate all these things, what I can do, basically I can print a sum. So yes, out sum, right? Pretty easy task. Let's do it. Okay, so this is how we normally do, right? Suppose he comes with another weight requirement that he wants only the sum of even numbers. Okay, that seems very easy task, I can also do that. Let's copy paste this code and introduce one if conditions. Maybe I can change the name as sum of even numbers. Okay, so in a list I want to only find the sum of the even numbers. Okay, this is very easy. If I modulus 2 equal to 0, okay, I'm gonna find the sum, otherwise I'm gonna ignore it. It's very easy, right? Again, he wants to find the sum of odd numbers. What do? We copy this, okay, and then we do an inversion here. Okay, maybe not equal to 0, are equal to 1, whatever you feel comfortable, and then we do it, right? We have created like this, and again he's asking, he wants to find only the sum of numbers that are divisible by 6. Okay, this becomes very noisy now. When you try to optimize this piece of code, it becomes already a mess, right? And then there may be future requirements again that makes it more complex, and you have to write a lot of lines of code. If you notice, we have repeated the same lines of code again and again. This is a crime in software testing. Okay, you may be booked under some sections and you may be put into a jail. Okay, don't do this. Okay, let's try to optimize this piece of code with some maybe some using Java 8. Okay, that's the power of lambda that I'm speaking about. Okay, so I have created a method now, and this method is going to return or print me a sum that let's say I have a numbers. I open a stream, and what I want to do, I want to use map to int. Okay, and I'm converting all the integers here. Okay, integer in this to an int value. Okay, guys, it is of list, it is of integer type. Integer type is different from your primitive type int, so I'm converting to a primitive type int, so that I can utilize, there is a method called a sum to find out the value of it. Okay, I can easily find out, this is for sum using Java 8, right? So I'll use a postfix to print it out, and now if you notice, I can easily, okay, I'm just printing the sum of it. Okay, it's gonna work the same way. Yes, that's good. So it is also printing me the sum. That's absolutely fine. And what I want to do, Amudan, you have new requirement now that you have to find sum of even numbers. Then I can just add filter. Okay, you pass me the predicate, guys. Okay, you pass me. See, this takes in a predicate, right? This is our use case. If you notice, it takes in a predicate of integer. It takes an integer and returns a true or false. Let's pass it from the client. Okay, so it's going to take in integer, sorry, the typo, and predicate. Okay, now here, from here I will pass it. Okay, what I want to pass, the predicate is, if I want to find the sum of only the even numbers, I will pass like this. Hey Amudan, then how will you find the sum of all the numbers? Okay, I whatever the integer that is coming, if I return a true, then it will find sum of all the numbers. See, it doesn't mandatorily that we have to use the arguments that is passed to one method. So whatever the integer that is passing, that's okay. I'm gonna, find sum of all the numbers. So I'm gonna return true for all of it. Okay. In second case, I want to find the sum of even numbers. So I'm passing I modulus 2 equal to 0. If I want to find more things, so let's say I modulus 3 equal to 0 0, or if we want to find the negation, okay, you can also do that, or you can write like this. Okay, so you can also create a variable, and then predicate variable, and then use negation as well for here. But yeah, this is gonna find sum of all these things divisible by 2, sum of all numbers, sum of again your some of number that are only divisible by 3. Okay, let's try to run it and then check how easy it is, right? So it is printing me all the values like what I want, but this time this is just using a single method. Again, guys, you don't have to do this step. Instead, you can also use reduce that we have learned before. So the initial value is 0. What I want to do, I want, if there are two numbers, I want to find the sum of it. Okay, because basically in the previous case we are doing the conversion operation. Okay, in the previous case I was converting from integer to int primitive type. This is some expensive operation, right? If the list numbers in the list are very huge, or the list size is very huge, the operation to convert from integer class to primitive type int is little expensive. So what I have done, I have used a reduce method, and this is your binary operator implementation that takes in two integers and returns you the sum. If you haven't understand what I'm speaking here, you may have to go 2 years back and then check my binary operator implementation where I have explained about these things. Good, guys, I hope you will find this video useful. Again, please share it with your friends, hit the like button, subscribe button, I see a lot of people are viewing my channel, but they are not generous enough to hit on a subscribe button. Guys, if you want to get more videos, please do subscribe, so that it also motivates me to create more videos. I hope I will find you in another video, with another useful video. Until then, tada, bye bye from home, and you guys have a good day. Bye.